Good morning, everybody. Welcome to this special webinar. It marks the launch of the CLiCC tool. My name is Elise Wall. I'm the project coordinator and a research specialist for the CLiCC initiative. In addition, I'm actually your webinar host for the next hour. I'm here with the current CLiCC team, and we're all very excited to finally share all of this work with the public. We're broadcasting from the Bren School of Environmental Science and Management at the University of California, Santa Barbara. We're an elite research university. Actually, US News and World Report just ranked us as the 5th top public university in the United States. The mission of the Bren School is to solve environmental problems. Bren has earned a worldwide reputation since its founding in 1966, a leading center for solution-focused collaborative research, and is a training ground for a new breed of environmental leader. Our multidisciplinary team of researchers have the passion to conduct groundbreaking research in chemical life cycle and risk analysis under the leadership of Professor Sangwon Suh. We have over 100 institutions turned into this webinar today: governments, industrial companies, consultants, nonprofits, and universities from around the world. We're really excited, did I mention? CLiCC is here because of your needs, and we hope that you find at least one of the hurdles you faced is addressed by our tool. So let's get started. Be sure to submit your questions to me using the Q&A feature if you see that in your toolbox with the webinar. We'll take some questions for a question and answer session at the end. So without further ado, this is our agenda today. We'll start with some congratulatory remarks from the chair of the board of the ACLCA, and then Sangwon will give you a comprehensive introduction to our tool and the science behind it, including how to use it. We'll have some partner remarks, people who are well acquainted with the CLiCC project. And then Beth Pitton-August will talk a little bit about how to support CLiCC. Sangwon will close with our vision statement, and then after that, we'll go into our Q&A. Now, I'm going to introduce Bill Flanagan. Bill Flanagan is the chair of the board of directors for the American Center for Life Cycle Assessment. There, he works to inspire and support an active and energized life cycle assessment community, where all stakeholder groups can collectively advance the science and application of life cycle assessment.
Hello, everybody. First, I'd like to congratulate the CLiCC team for their achievement. Years of effort have gone into the development of the tools that you'll be hearing about today. Let me provide some context regarding why this is important. LCA is a powerful methodology for assessing the environmental impacts of products and services. In order for LCA to be effective and influential, one needs to be able to have data for the materials and processes that are involved. And as those of us are involved in this practitioner of LCA, this can be very time and resource intensive. A variety of life cycle inventory data sets are available, but it is difficult for these data sets to keep up with all of the new chemicals and materials that are always being developed. CLiCC provides a new way for researchers and sustainability experts to explore the potential environmental impacts of chemicals, both existing and new. I anticipate that this will be a valuable addition to the LCA practitioner's toolkit, and I look forward to seeing how the community leverages these tools to tackle and solve sustainability problems for the benefit of society. Again, congratulations to the CLiCC team. Back to you, Elise.
Thank you so much, Bill. Now we're going to get well acquainted with the CLiCC tool. Professor Sangwon Suh is the director and the lead principal investigator of the CLiCC program. Since 1997, he's been contributing to the theoretical foundations and practical applications of life cycle assessment and industrial ecology. Dr. Suh was appointed to the International Resource Panel of UN Environment and to the Intergovernmental Panel on Climate Change. Dr. Suh's work has been recognized by the Robert Laudiz Award of the International Society of Industrial Ecology and the Leontief Memorial Prize by the International Input-Output Association. I'll now pass it over to Sangwon.
Thank you, Alice. Thank you, everyone, for joining us today. I share Alice's and Bill's excitement about this launch. Our dedicated students, researchers, faculty, and our partners have been working together over the last 5 years toward this point. It means a lot to us to finally be able to launch our tool. What is the CLiCC tool? In short, it is a web-based tool for assessing chemical life cycle environment impacts as well as human health and ecological risks. Our researchers developed the science that enables our tool and published those results in leading peer-reviewed journals. We believe that we have contributed to the advancement of science so that we can understand the behavior and impacts of chemicals better. In addition, we have collected massive amount of data and connected existing data sets through APIs. We have collected over 240,000 experimental toxicity data points covering 61,000 different chemicals, and we developed lifecycle inventory data for 900 building block chemicals with which you can build your own lifecycle inventory for your chemicals. We have collected climatic and environmental conditions over 10 years of time frame for 12 different representative locations around the globe. Finally, we have developed the computer programs that links science and the data and incorporated them into a web-based platform. Now, why did we start this long journey 5 years ago? First of all, chemicals are an essential component of modern lifestyle, but it is also important to recognize the potential harm that some of these chemicals may cause to the environment, human health, and the ecosystem. The problem is that we are creating new chemicals at an unprecedented rate. When we started our CLiCC program 5 years ago, I remember that the CAS registry just broke 100 million mark. 100 million. That is already a lot. But when I checked again recently, it has reached 140 million. Every day, we are adding about 25,000 new chemicals to the list. But unfortunately, the rate at which we can analyze and understand the life cycle environmental impacts and human health risks of these chemicals is much slower. This mismatch between the speed of chemical discovery and the speed of our LCA and risk assessment created a structural problem that will only deepen over time. This is not only an environmental problem, it is also an economic problem. Because LCA, animal testing, and risk assessments are not cheap, especially when they are multiplied by the increasing number of chemicals to be analyzed. Furthermore, producing or using chemicals without understanding their potential impacts can be a future liability issue. Finally, regulatory agencies also need a tool to assess the growing number of chemicals quickly and cost-effectively. So the question that we were facing was, how can we reduce the time and cost needed to understand the life cycle impacts and human health risks of chemicals? How we are addressing this daunting question? First, again, we believe that solid science is the foundation. As an academic institution, we cannot care less about scientific integrity. Science is not perfect, and there are still a lot of things that even the best science cannot explain or predict. We will continue to work on fundamental science to keep on improving our tool. Then it is really about data. As we talked about before, we have collected a large amount of experimental data, and we are using APIs to connect existing data platforms on the internet. Next is the use of predictive tools. Our system prefers experimental data whenever they exist. But if there is no experimental data, then the system tries to estimate them using the best-in-class predictive tools, be them ensemble QSAR models or artificial intelligence applications. Finally, we take uncertainty very seriously. We run large-scale Monte Carlo simulation to provide the information on the distribution of the results so that users can make an informed decision. What is unique about CLiCC? First of all, it is easy to use, which is very important. It's a web-based platform. Anyone can just log in and start to navigate. Second, we are connecting a wide array of existing data sets. The amount of data that we have collected and connected is unprecedented. And we are using a lot of predictive tools to enrich our data system. And transparent methodology is also very important for us. Quantification of uncertainty, we take it very, very seriously. And I think it's also very important for us to consider not only just life cycle assessment or risk assessment in separation, but together. for a better decision making. What can you do with CLiCC? There are three main groups of functionalities that CLiCC offers. First, it is about screening level chemical reports. Second, it is predictive life cycle assessment. And third one is human and ecological risk assessment. So when you go on to the website, www.click.net, you will see this page and you can already enter the chemical of your interest there. But you can log in using the link on the upper right corner. When you log in, you are asked to create a project, and then you are given the three choices that you are seeing here. The one is screening level analysis, and second one is life cycle assessment module, and third one is risk analysis module. When you choose the first one, which is the screening level analysis, then you have again three options under it. These are the three types of reports that can be generated under the screening level analysis module. The screening level scorecard, which I will show you briefly later, and the screening level chemical properties, and safety data sheet support. So it can generate the material safety data sheets. And if you choose the second module, life cycle assessment module, then again, there are two choices that you can make. One is life cycle inventory estimate, and the other one is life cycle impact assessment. Third one, risk assessment module. It has 5 modules, sub-modules there. One is chemical release module, chemical specific environmental concentrations module, which is basically fate and transport model. And then there are human health risk assessment module, ecological risk assessment module, and their combination there. This is a screenshot for the screening level analysis module, and we have a pre-populated 2 chemicals over there. So these 2 chemicals are dichloroethane and benzyl alcohol. Both of them are widely used as a paint stripper. As you can see that the complete button, which is you are seeing over here, if you can see my cursor over here, it says complete with a green checkbox. It means that the analysis has been done, already calculated, so that you can view the result. If you view the result, it will look like this. First, it provides the cradle-to-gate life cycle impacts using our predictive tool, machine learning algorithm, for both of those 2 chemicals. Please pay attention to the model confidence column here. So it shows using a simple bar representation how confident the model is in predicting these life cycle impacts. So it has cumulative energy demand, acidification, eco-indicator, and climate change, etc. And you can really see, what are the differences and trade-offs between these 2 different chemicals. It also provides hazard indicators, be them ecotoxicity and human health impacts. And as you can see, we have created in the middle, so for example, in a carcinogen question mark here, whether it's a carcinogen, then we say yes, and if it's not, it's no, and we have created a non-inconclusive in the middle following the advices of our partner. So again, you can see what are the differences, what are the trade-offs between these 2 different chemicals. So this is a screenshot for lifecycle inventory module, and currently we have not connected this parametric lifecycle inventory calculation. We are still working on that, but in principle, we let the users to choose the process parameters like the reaction efficiency, wastewater treatment efficiency, etc., so that you can generate your own lifecycle inventory based on the process conditions that you choose. And you can export the resulting lifecycle inventory to an Excel file and upload that to your preferred lifecycle assessment platform. Finally, this is the screenshot for the risk assessment module, and risk assessment is necessarily much more complex, as you can see, and there are more buttons down here. And of course, you can always override our estimates by your experimental data if you have. Human toxicity, ecological toxicity data, these are the modules that need to be run in order for the risk assessment to be completed. So once that is completed, then you can view the result like this. So for example, the risk assessment module can estimate the concentration over time. These are the number of days for San Francisco and Zurich Those are the 2 global locations that we have already pre-populated in our data system. And you can see because of the rainfall, precipitation, and wind, there are fluctuations over time. And there is quite striking difference between these 2 geographies, as you can see. Beware that these are log scale, so there are quite significant difference between them. But the important thing here is that both of them are under the threshold. This is daily concentration in air. This is freshwater concentration. This is another, I think, concentration here. And this is a risk result. And we are comparing the risk assessment result of these 2 chemicals relative to the reference dose. And we can also view the breakdown of the exposure pathways. Finally, the uncertainty module allows you to see not only the deterministic value, but also the distribution of the result that we are generating. And it also further shows where are the main contributions coming from in terms of the uncertainty of the result. It seems that the daily intake from ingestion of exposed product for one of those chemicals, benzyl alcohol, is particularly uncertain, so that you can focus on refining those parameters that are pertinent to the estimation of this part in order to improve the overall uncertainty of your estimates. In summary, CLiCC tool offers the users 3 groups of main functionalities, and they are screening level reports, lifecycle assessments, and risk assessment. And each of them are subject to uncertainty analysis shown here. For further details on our functionality and how to navigate our tool, please visit our YouTube channel, and you can listen to the beautiful voice of Alice again there. Finally, a few words on our team and partners. The CLiCC project supported and nurtured next generation leaders, scientists, and environmental professionals, and many say that the experience under the CLiCC project has been critical in their career success. And not surprisingly, our researchers go out and have landed all kinds of awards. We are very proud of them. I thank our CLiCC team for their dedication and camaraderie that enabled us to arrive at this important juncture. Thank you. And I also thank all the partners for their generous support, without which we could not have achieved what we did. Thank you very much. I will bring the microphone back to Alice.
We'd now like to turn our microphone actually over to some of these partners who have experience with the CLiCC program. First is Dr. Rich Helling. Dr. Rich Helling is the Director of Sustainable Chemistry for the Dow Chemical Company. For 30 years, he's worked in research and development, manufacturing and sustainability, and now he leads Dow's use of life cycle assessment and other sustainability metrics.
Thanks to UCSB and to the CLiCC team for undertaking and advancing this ambitious and very exciting project. I personally have greatly enjoyed and benefited from my interactions with the project team over these past years. My perspective is really that of a life cycle analyst, one who has a strong interest in estimating life cycle inventories and life cycle impacts of materials. In particular, I'm often involved with developing life cycle assessments for products that we produce that have many material inputs. Some of them we make and some of them we purchase. And so I have a strong interest in the cradle-to-gate life cycle impacts for materials that we purchase, especially those that may not be in existing databases. And this happens a lot. The methods used by the CLiCC team evolved over the course of this project as they got input from the advisory board. And I think they've ended up with an approach for the life cycle impacts that is both very reasonable and very useful. This part of the CLiCC tool was in part developed on the depth of information in Ullman's Encyclopedia of Industrial Chemistry. I know they used other sources, but that as an example just reflects the breadth of the chemistries that are included in the tool and that was used to develop the neural networks and the correlations to come up with the life cycle impacts. And the tool has provided me with what I think are reasonable estimates for carbon footprints and energy demands for a variety of materials. As a specific example, during some recent tests, I used the CLiCC tool to improve selections of material models in my work. So I generated estimates using the tool for the carbon footprints and the cumulative energy demand, in particular for a couple of functional ingredients in a formulation, which were quite different. So I also estimated what those in turn were made from, since I didn't have those completely in other sources either. Some were in EconVent, but not all. I needed to have other sources of information to come up with estimates for them. The CLiCC results, and in particular, the data quality indicators really helped me select the best quality inputs or to put some more effort in the lower quality ones. So those data quality indicators are really important to understanding the output of any software tool, but in particular, one that we're using to do for life cycle assessments. As a side note, during these tests, I also found the online videos were helpful in getting me started in using the current implementation of the tool. I wouldn't yet use the tool for comparisons or absolute statements related to the toxicity-related metrics, particularly those that go beyond acute toxicity, as there are not accepted, I think, QSAR methods for all of these. And this is really still a field that I think needs more human expertise, judgment, and data. But similar to toxicity metrics in LCA, otherwise, the tool can be used as a way to flag something that needs further investigation, potential hotspots or issues that you really need to dig into a little bit more. So in summary, for me, CLiCC today is a very useful tool and a great addition to the LCA toolbox for the life cycle inventories and impacts and estimation of these well-established life cycle impact categories. So Elise, back to you.
Thanks so much, Dr. Helling. Next, we'll hear from Dr. Xiaoying Zhou. Dr. Xiaoying Zhou is a senior hazardous substances engineer with the Department of Toxic Substance Control at California EPA's Safer Consumer Products Program.
Good morning to all the web attendees, and thank you everyone for making this happen. And this is a terrific event, and congratulations again to the team for the launching of the CLiCC tool. And back to 2014, the Brand School and DTSC started to collaborate on a project to explore and develop the potential synergies between the CLiCC tool development and the Safer Consumer Products Program. So I need to, bear with me, I got to go. And so I need to throw a little bit more context here. The California Safer Consumer Products Program intends to promote safer alternatives for hazardous ingredients in consumer products sold in California. So manufacturers must go through alternative analysis to compare the chemical of the concern in priority products with its potential alternatives, which could be a chemical-to-chemical replacement or reformulations or material change, or could be a process or product redesign. And under the California's this alternative analysis framework, a very broad range of factors need to be considered comprehensively to avoid burden shifting between different adverse human health and environmental impacts and their interaction with the different exposure pathways and life cycle stages. But performing a full risk assessment and life cycle assessment usually requires significant expertise and resources, which may not be available to many small and medium-sized companies. So one of the major goals of this earlier partnership was to develop a streamlined and screening-level risk-based tool with a life cycle perspective, which could be used to fit the needs of the alternative analysis. And also in our framework, we regulate the product chemical combination, so not just the chemical itself. So this tool needed to be also product focused, meaning the chemicals analyzed by this tool could be linked back to specific product relevant applications and end-of-life release modules. And in addition, historically, the alternative assessment only used for the comparison of the existing chemicals, but during our partnership, we also want to, the CLiCC initial design could also include alternative assessment use scenarios to promote safe by design innovations at very early stages of the new chemical and product development. And so a little bit fast forward here, and last week here in Sacramento, we just had this second International Alternative Assessment Symposium to discuss what are challenges and needs for the alternative assessment and adoptions of the safer substitutions. So one of the biggest challenges we are facing in this area is data availability and quality issues, particularly in the areas of the toxicological data, especially ecological hazards and exposure data, product ingredients and chemical use information, and the life cycle related information. And also everyone in this AA community acknowledges the uncertainty is one integral part of the AA process to inform decisions. And because this CLiCC tool has this major feature by bridging the existing data and the tools applied in traditional fields of the life cycle assessment, risk assessment, chemical process engineering, and with the recent research development of the computational tools and the predictive techniques. So that's really helped to address those data gaps issues to some extent. And in addition, it incorporates the uncertainty analysis in the results to allow us to get a better pictures of what is most important parameter or properties we should focus on. And so we can see this CLiCC tool has a lot of the potentials to help address the data gap issues, and while providing some insights about the nature and the amount of the uncertainties involved in the AA process. So hopefully we can see more case studies and real world examples to apply this CLiCC tool to alternative assessment and alternative analysis and see how this tool progresses. So thank you again for the opportunities to share those comments. And I find that I need to just insert a little bit a disclaimer, and those comments only reflect my own personal opinion, not representing the agency's policy position and formal interpretation of the regulations. So back to Alice. Thank you.
Thank you so much, Xiaoying. Next, we'll hear from Doug Mazeffa. Doug Mazeffa is the Product Sustainability Manager for the Sherwin-Williams Company. He oversees the company's sustainability and product safety programs. Doug has extensive expertise in the development and publication of product category rules, lifecycle assessments, environmental product declarations, and other sustainability standards. Doug?
Thank you very much. And, want to join my colleagues in congratulating the CLiCC team on some great achievements, and appreciate the opportunity to speak today. And so we've been involved with the CLiCC program since, I believe, early 2015, and actually had done a rather complex case study kind of throughout 2015, and have done some work in the interim until the launch now. And really the interest with CLiCC, we were initially connected actually through a supplier of ours, is that, we're getting a lot of push. So most folks know Sherwin-Williams is a paint company, but, truth be told, although that's a big part of our portfolio, we do all types of coatings, whether it's for, the touch screen of your cell phone to the inside of Coca-Cola cans or what have you. But on the building kind of architectural front, there's been a big push towards product transparency in terms of hazard and environmental product declarations, so sort of an LCA of products. And so on the hazard piece, a lot of the programs that are out there on the voluntary front have been more kind of fixating on raw material hazards. And when you're making a reactive product, that as soon as you start mixing raw materials, some of those materials cease to be what they once were and kind of react and become something else, or become encapsulated or are bound in a polymeric matrix, whatever that might be. It's sometimes you focus maybe too much on an SDS or something like that, and you want to understand better what's happening to your product, how folks can be exposed to it, how things degrade, what the fate and transport is. And so CLiCC really represented an opportunity to, marry some of the life cycle assessment concepts along with, the more kind of conventional hazard assessments with fate and transport and exposure assessments. So, we could go in and, look at this sort of holistically. And I really want to stress that marrying, because, so much of what's been done has maybe not looked at life cycle thinking in a broad sense. And so you can have some, kind of unintended consequences or burden shifting if you go from, product A to product B, or material A to material B, if you don't consider things like functionality. If you need a gallon of this product versus 5 gallons of the other product, that should come into play. Or if this degrades into some very, undesirable things, whereas the other one does not, these sorts of things should be tracked, and CLiCC can really help doing that, or help do that. And, controlling some of the assumptions, whether it's on the LCI side or on some of the fate and transport side, we might have products that are earmarked for, your garage floor versus a factory or something, and things like air exchange rate, occupancy, all those variables change. And so having the ability for a company who manufactures a wide variety of products to be able to, control some of those data points, since we have the data, is just a tremendous benefit. And on the lifecycle inventory side, I think last time I checked, we have something like 10,000 raw material suppliers. And so, there are inventories available commercially or from some of those suppliers that are great for our environmental product declarations. But oftentimes, a lot of the additives, or if there's novel chemicals that we're using for a product, there's not going to be any data available. And so having that predictive inventory capability really could be a game changer for us, because you can use analogs. There's kind of clever ways you can get around it, but you don't always feel good about that. And so something, with CLiCC's kind of rigor and kind of capability and kind of machine learning capabilities could really be huge. So, we're, really excited to see what the future holds for CLiCC, certainly hoping to stay involved with it. It's just the one-stop shopping of the kind of toxicological piece, the hazard piece with the LCA piece, as well as kind of being able to look at those life cycle thinking sort of principles, really just see a lot of possibilities here for our products, and just in terms of how we understand and communicate, the potential impacts and benefits of what we're manufacturing. So with that, thank you again, and I'll hand it back over to Elise.
Thanks so much, Doug. We have one more partner speaker to hear from today, Dr. Lynne Olson. Dr. Lynne Olson is a corporate scientist for global sustainability at Ecolab. Dr. Olson helps drive top-line growth for Ecolab and its customers by embedding sustainability thought leadership into innovation management, product offerings, and standardization of sustainable growth benchmarks.
Thank you, and thank you for the opportunity to speak. I guess good news and bad news about being the last panelist. I really appreciate and agree with most all of the comments from the panelists, and so I don't have a lot left to say, but I guess first, Ecolab has had the opportunity to be involved with the CLiCC project pretty much from the beginning, and had the opportunity to attend in person at the beautiful Britain Center, the couple of the summit meetings. So I'm just thinking, and you flashed the picture of the project team way too fast for me because I was looking at the faces and, you know, just so excited for you guys to come to this point. I really understand all of the hard work, and I was so excited also to see Jess won an award for all of her hard work. So I think, you know, everybody should know that this is truly an exciting day. And, you know, I just like to, as I had the chance to be face to face with this group, I was really impressed with, you know, number one, the skills that Sangwon Suh brought to bear on this problem of, you know, data analysis gaps. Tons of expertise. But I think what impressed me the most was the dedication. I mean, this is a hard slog. It's breaking new ground. You know, one of the things they wanted me to comment on was the timeliness. And as I was thinking about how do you comment on the timeliness in the context that this is a leadership project, it's something that's never been done. So it's hard, you know, we needed it years ago, really. But, you know, I think it's very timely to use AI to bring to bear all the information that's available, but hasn't been, you know, as, you know, somebody said, one-stop shop. So I think this is really, you know, it's a hard project for the students and researchers in that, you know, you don't get the recognition because you are breaking new ground. You're, you know, plowing territory. It will be really exciting to see how this moves forward and gets acceptance. So how was Ecolab? Why were we part of this? We're much more on the practical side. You know, how can this information be used to support our day-to-day activities? And so my role is to integrate sustainability into the product development process. And to do that, we really need to have the best possible information about the ingredients that we select in developing our products. So, of course, we rely on folks like Dow, one of our key suppliers. And so very happy that they are also using this tool. But we need to understand, you know, the background of some of the key chemicals that we don't have a lot of information on, and understand how their selection stacks up and what other options are. So we also participated, and the reason the face-to-face I think was so important is wanted to bring the, you know, practical perspective. You know, how could this be used? And one of the first places that I anticipate Ecolab will use it is in even SBS authoring, understanding where we have newer chemicals, making sure that we're giving the customer the best and most appropriate information in our safety data sheet. So I'm looking at not only using this as, you know, product selection, ingredient selection, and helping our research associates make the best possible decision, but also in making the best possible communications about our products to our customers. So I'll be very interested to see how this evolves, and, you know, really encourage everybody on the phone to, you know, I know, you know, since it is new, it takes time and energy to learn, but I encourage, and I'm going to encourage folks within Ecolab to learn how to use the tool and see, you know, I think it'll be exciting to see how we can leverage it. So the last thing that, you know, they kind of asked a comment on is, you know, how would I like to see it evolve? And right now it's focused on, you know, individual substances, pure substances. I'm interested to see, and, you know, I feel a little pain to put this because it's so much work has got it to where it is now, but I, of course, and I think the team knows that, would like to see how it could be used to characterize complex mixtures in a life cycle assessment context. So that is really appreciate the opportunity to express my perspective and Ecolab's perspective, and appreciated the opportunity to meet this, fantastic group of researchers and students. And again, I'm just so excited that the launch day has come, and congratulations. And I'll hand it over to Elise.
Thank you so much, Lynn. I think I speak on behalf of the entire team when I say that we're so grateful to have had such amazing partners with us through this process. We really couldn't, make an attempt to meet your needs without you communicating them with us so well and being with us every step of the way. In our last few minutes, we'll actually talk a bit about how everyone on this call can get access to CLiCC, how ongoing access to CLiCC will work, and then wrap it up with our vision for the future of CLiCC now that the tool has been built. As Bren School's Director of Development, Beth Pitton-August works closely with the Dean, faculty, and staff of Bren to raise funds to support initiatives at the Bren School. Her focus is on building community and business connections that support the Bren School's research related to corporate environmental management, especially helping to tackle priority problems for alumni working in corporate environmental management roles. Beth?
Good morning, everyone. I want to start by thanking our partners again for their contributions to help us get this far and for being with us today. It means a lot. CLiCC was developed with funding from the National Science Foundation and the EPA. But moving forward, with each run incurring cost, we're looking at a model now to maintain and continue to develop the CLiCC tool with support from users. User support will accomplish a number of things. It will help ensure that we stay online, provide support for basic functionality of the CLiCC tool, and of course, maintaining the tool. It will also help us provide user support, customized options, and also help accelerate computation of results, build capacity, and continually improve the tool. As Lynn just mentioned, we have a vision for a number of new functionalities to support daily work. Now we need supporting partners to help keep the tool accessible. Without supporting members, CLiCC will not be online at all. And all these years of hard work, we want to continue, and as the name entails, the Chemical Life Cycle Collaborative is a community of users, like-minded folks who care about chemical sustainability and environmental and health hazards reduction. As CLiCC expands its offerings over time, members of the CLiCC Collaborative can solve more problems together. You've heard from 3 of our users, actually 4 of our users. Some of the benefits they've described are improving selection of materials, addressing data gaps for alternative analysis, marrying LCA and hazard inputs, creating a one-stop shop, particularly taking advantage of predictive inventory capabilities and AI, and helping to communicate to customers with transparency and with real important information that we all want to know. And I would also like to say that these industry partners have been so helpful during development. They've provided data sets, back-end code from existing resources, assistance with validation and testing, and we really aim to be a hub for existing resources in the future. So if you, listeners here, have any ideas of resources that you think would be useful to incorporate into the CLiCC tool, we invite you to share that with us. We want to hear from you. We'd love to hear what you think about how you would fit into the CLiCC Collaborative. We also want to invite you as a listener today to play with the tool, get a sense of how this tool might be useful to you. We're offering a 90-day free trial. Contact us after the webinar. We'll put the contact information up there, and we'll set you up with a free 90-day trial. We also invite you to refer a colleague. If there's someone in your network that you think could make use of this tool, please introduce them to us, and we'll be happy to extend that free offer to them as well. Thank you again for your interest, and we look forward to engaging with you in this conversation. Now I think I'll hand it back to Sangwon.
Thank you, Beth. It was really heartwarming to listen to the comments from our partners. I really appreciate your generous support to our CLiCC project. So what I'll talk about from now briefly is about where does this take us to. But before we do that, just one thing that I wanted to clarify is that each run of CLiCC incurs cost to us. So we are using cloud computing platform by Amazon, AWS, and we are relying on Amazon's cloud computing and storage capabilities in order for us to offer the service through the CLiCC website. And when you run a model there, you just by clicking a run, basically it incurs cost to us, and currently we do not have the means to recover that cost. And as you all know, that federal grants, once it ends, then there's no extra charges that we can request to them. So it really becomes an important issue for us. How can we sustain ourselves? And over the past 5 years, we worked very hard to produce the science and the tool that enabled the CLiCC, and we really sincerely hope that the CLiCC can continue to serve the community going forward. So for that, your support is crucial. So obviously, I would like to consult our advisors and our partners to draft the next chapter of CLiCC beyond this point. But these are some of the ideas that I had in mind. And obviously, nothing is set in stone. And we would love to consult you, and I would appreciate your ideas going forward. I think that this CLiCC project offered us an opportunity to create a community of chemical life cycle assessment and risk assessment professionals. And I think we would like to nurture and cultivate the community around this area. And that also includes recognizing champions and let them lead the community by being a role model in the community. So we want to kind of explore the ideas of having institutional platform around the CLiCC and chemical life cycle assessment and risk assessment in collaboration with ACLCA and CTEC. We are friends and members of that as well. And we are also thinking of organizing annual meetings and recognizing some champions using CLiCC Chemical Sustainability Award. We would like to see the users of the CLiCC tool and how they improve the life cycle impact and the human health risks of chemicals through the use of the CLiCC tool. Throughout the development of the CLiCC tool, I have seen a lot of good intention to protect the environment and human health of the chemicals. And I think that we'd like to bring those good intention into our community really and recognize those champions through these kind of the award opportunities. And many of the users asked us about the compatibility with the lifecycle assessment and risk assessment software tools that are out there. We will continue to work on that and make sure that our results are compatible with the mainstream tools that are out there, so that you don't have to run into the problems with the compatibility going forward. And we are also interested in hearing from you about the customized tool development opportunities. Some of the participants already asked about the questions on alternative analysis, how far we can support the alternative analysis. Can there be customized solutions exclusively for alternative analysis? We are very much open to those conversations, and we'll be happy to support the needs that you may have, including the alternative analysis. And we are still working on a number of areas of development, and that includes testing and validation. And part of our tool, part of our results are tested and validated. But our testing and validation continues. We are seeing this moment as not as the end of the CLiCC project. It's actually new beginning of the CLiCC project, and we will continue to improve on our CLiCC program. And we will be working also on eco-invent compatible parametric lifecycle inventory so that you can adjust the parameters and generate the new result. And as Doc mentioned, we do have the capabilities and we already have generated some of those results, but they have to be fully integrated with the web-based tool, which we are currently working on. And we will continue our effort to reduce uncertainties. And as Rich mentioned, the predictive tools and QSAR, still there are quite a bit of uncertainties around it, and reducing them is critical for us to be able to provide reliable information out of our tool. I will tell you a little bit more about what we are currently working on in that direction. And as I talked about, institution building and sustainability planning, meaning that, well, how can we sustain ourselves going forward financially and also institutionally? That is, I think, big question that we are trying to address. So I would like to just showcase one of the works that we are currently working on. Our researcher, Runsheng Song, is working very hard to develop the predictive modeling for ecotoxicity, and he has compiled ecotoxicity data for 8 aquatic species, and he developed the artificial neural network model, and so far it seems that it performs pretty well, and we have generated acute toxicity result for 8,000 chemicals in ToxNet. And with that, what we could do was to develop the species sensitivity distribution, which is an essential tool for ecological risk assessment as well as ecological life cycle impact assessment. So these are some of the examples of how we use this type of predictive capabilities to generate the species sensitivity distribution for 2 different chemicals here. So we will continue to work on this cutting edge science going forward. In terms of the institution building, it is so important for us to secure our financial support so that we can operate day-to-day maintenance and the website and our cloud computing platform. And also, we would like to create a governance structure. As Beth mentioned, we would like to recognize board members from our platinum partners, and they will be able to engage with us and decide what will be our next big tasks to be solved, and what are the new directions of our tool development. All those things we would like to engage our board members to those important decisions. And we would like to continue to identify joint project opportunities and case studies. As Lynn mentioned, we need to do more case studies and generate more use cases, and then we will continue to work on that, and for which your suggestions and ideas will be very much welcome. So with that, I would like to bring it back to Elise.
Thanks so much, Sangwon and Beth, and all of you who are tuned in today as well. We've really had a great time sharing all of this work with you. So with that, thank you so much for attending. Again, you'll get that email tomorrow with the slides and the recording. In the meantime, we'll approve everyone who sent us an email to go and play around with the CLiCC tool. Let us know what you think, and please have an excellent rest of your Thursday.